Well, pi is 1, so according to my relation up here, at negative pi over 2, the value is negative 1. And at pi degrees, the value of the function is 0. But negative pi is going to be negative 0, which is just 0. And at 3 pi over 2, the value of the sine function is negative 1. So at negative 3 pi over 2, I multiply by the negative, and I get negative 1 times a negative 1 is just a positive 1. And at 2 pi, 0 and negative 0 is both 0, so it looks like this. Okay, so it's a little off scale. I mean, this is narrower than this, but you get the idea how it oscillates every 2 pi degrees. Actually, because from here to here is pi, and the distance from here to here is pi, I can actually get all my values between negative pi and pi. And when we start talking about inverses for the sine function, we're actually going to restrict it to that range. But for now, it's sufficient to say it repeats every 2 pi degrees. And we'll talk about that in a second. Now, for the cosine function, we do the same type of thing. Oh, I also might want to note a couple things here, is that you'll notice that it's increasing from negative pi over 2 to pi over 2. Okay? And where is it decreasing? It's decreasing from pi over 2 to 3 pi over 2. Right? It's decreasing here. And it's also decreasing from negative 3 pi over 2 to negative pi over 2. Okay? The domain for this function is going to be all real numbers, negative infinity to infinity. The range, well, my biggest value is 1, my smallest value is negative 1, and you can see it hits all values in between. So the range of this function is going to be negative 1 to 1, all those values in between. And the zeros are going to be at multiples at pi. So the zeros are going to occur at multiples of pi, where just k is an element of the integers. This is some integer. Negative 1, negative 2, 1, 3, 5, anything like that. And we're going to have, okay, and those are general properties. I believe those are also all the properties it gives you in your book. And it's going to be, you can also notice it's going to be 1 or negative 1 at odd multiples of pi over 2. Right? So if you have an odd multiple of pi over 2, say like 3 pi over 2 or 5 pi over 2, it's going to be 1 or negative 1. Okay? So you can write that one down too if you like. So these are some properties for the sine function. The most important ones, well, they're all pretty important, but the fact that it's an odd function, and and the period, which we'll talk about in just a little bit, the period for this function is going to be 2 pi. Now, what I mean by that, it's the smallest positive number by which the values repeat, right? Which any value will repeat. And I'll talk about more of that in a second, but the basic idea you can see is if we go from 0 to 2 pi, the function gets all its values within that range, and if we did another 2 pi again, we'll get all its values there. But we'll talk about that in a couple slides, or whatever you want to call these. Okay, and we want to look at now. We can look at the cosine function. Now the cosine function is going to be a similar idea. What we're going to do is we're going to start out by just drawing as we did before. We have 0 degrees on the axis, and then we'll just do the quadrantals because they're easy. So we'll do pi over 2, and we'll do pi, and we'll do 3 pi over 2. And then what we'll do is we'll put a 2 pi over here like so. And we go the other direction, we'll do negative pi over 2, negative pi minus 3 pi over 2, and we'll minus 2 pi, right? Now, if we want to go to our chart again and we want to plot these, again, we just, for the sine function, for the cosine function, we just look at the x-coordinate. Well, the cosine of, when we're at 0 radians, the cosine value is the x-coordinate on the unit circle, which is 1. So here we're starting at 1. And again, this is the cosine of t. And I'm going to give you some information we'll see in a second, but this is called an even function. And what the even function means is that the cosine of t is equal to the cosine of negative t, is what that means. Okay? So according to our chart, at 0 degrees we're 1. And if we look at pi over 2 degrees, we're 0. And at pi degrees, if we look on our chart, we're going to be negative 1. At 3 pi over 2, if we look at our chart again, we'll see that it's 0. And at 2 pi, we'll see it's positive 1. So again, this function is going to be 2 pi periodic because you'll see it doesn't repeat all its values, and in this case, the one it's waiting to repeat is that positive 1 until it gets to 2 pi degrees. The cosine function is going to look like this. And it's an even function. It means that the value at pi over 2 is the same at negative pi over 2. So they're both 0 here. And it basically means the minus sign in front of the t doesn't matter. You can just ignore it. And it just means the value at pi in both cases is negative 1. The value at 3 pi over 2 in both cases is 0. And the value at 2 pi in both cases is 1. So the cosine function is essentially going to look like this. And again, as we had before, the domain, it's an even function. And the period, as I said before, is going to be 2 pi, but the domain is going to be all real numbers. The range, as before, is going to be negative 1 to positive 1. Notice that it's going to be decreasing from negative 2 pi to pi. I'll just put DEC for decreasing. It's decreasing from 2 pi to pi. It's also decreasing from 0 to pi. And it's increasing from negative pi to 0. And again, these patterns will just keep repeating, and pi to 2 pi. And again, you can extend these patterns past 2 pi. In negative 2 pi, just restricting myself to this domain filament. Well, at least for drawing it. I can't draw all real numbers. Okay. So we have that, and we said that the period was 2 pi. And what else did we have? It's an even function. And the zeros the zeros are going to occur at odd multiples, so it's going to occur at 2k plus 1 times pi over 2, where k is any integer. So it's going to occur at odd multiples of pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, 8 pi, 9 pi over 2, 11 pi over 2, negative 3 pi over 2, negative 5 pi over 2, etc. And you also might want to note that at multiples of pi, it's going to be 1 or negative 1. You can write that down if you like also. So that's the cosine function. Okay. Now, just to get an idea, you might want to see of why it's an even function. If I guess I could show it real quick as to why it's an even function. But suppose just say think of the unit circle here. If we start at 0 degrees and we go forward by pi over 6, right? Now, where pi over 6 is 30 degrees, we can draw our triangle like this, and we're going to have the x-coordinate at this point is going to be the square root of 3 over 2, and the y-coordinate is going to be 1/2, okay? And we can do the same thing over here. If we go a negative pi over 6 as our reference angle, then on the unit circle, our x-coordinate over here is also going to be square root of 3 over 2. And the y-coordinate here is a negative 1/2, right? Basically, because our reference angle in both cases is pi over 6, but here we're in the fourth quadrant, so the x has to be negative, and the x has to be positive still. We're on the positive x-axis. The y has to be negative because we're on the negative x-axis. So you see, it didn't matter if we went 30 degrees to the negative or 30 degrees to the positive. For the cosine, the value didn't change. All that mattered was the angle. But going a positive versus a negative, we noticed that the results differed by a negative sign for the sign, and that's an example indicating it's an odd function. It doesn't prove it, but it gives you some evidence there, and maybe some intuition of what's going on with it. Okay. So now what we're going to do is we're going to define what a period is. So we'll define what a periodic function is. So periodic functions. Okay. And we'll say a function f is periodic if there exists a positive number p, which is greater than 0, such that f of t plus p is equal to f of t for all t in the domain.